Okay, we are going to do some problems here from page 456, number 26 and 27, of vector problems here. So I'm just going to read the directions here. It says navigation, the speed of a powerboat in still waters is 35 miles per hour. It is traveling on a river that flows directly south at 8 miles an hour. So we're dealing with a boat, and it is going 35 miles per hour if that water was perfectly still. That is 35 miles per hour is going to be basically the magnitude here. The river itself, and there's a current that goes 8 miles per hour, and again that will be the magnitude of the river, and it is going directly south. Okay, so now we're going to read problem number 26 and then apply the vectors and coming up with the three components: the magnitude, the ordered pair, and the direction. 26. This boat heads directly west across the river. What is its resulting speed and direction of the boat? Round the answer to the nearest 10. So that's kind of confusing by itself. So what we want to do here is just try to draw a river here. Here's the boat. This guy is on a boat. He's got a boat engine. He wants to get across this river. This is the river. The current is going south. And he wants to go directly west. And I guess there'll be a house here that he wants to get to. Okay. So he's going to try to do this. And he's just going to send his boat. Let's pretend he's not really paying attention. He's just going to send the boat this way, west. This is the vector. The magnitude of this guy is 35 miles per hour. So I'll put 35 right there. Now, there is a current going south. And so the current is going this direction, directly south. And I'll put the number 8 for the magnitude of that guy. So what this guy was planning to do, now if he doesn't pay attention, he's going to realize he doesn't hit the boat, which is directly west. He's actually going to travel like this red line here. And this is the true vector that he's going to end up doing. He wants to go west, but the current pushes him south. And if he's not paying attention, this is where he's going to end up, right here. Okay. They want to know, and this is the end result. They want to know the resulting speed, which is the magnitude, and then the direction. So there's two things here. We're going to get the speed of that red line, which is really the magnitude of how long that line is. And then we will also get the direction. And in order to get direction, we need this angle here, and I'll call this angle A. And of course, north, south, east, west. Okay. To get the speed, the magnitude, hopefully you can see this right triangle here, and this will simply be an a squared plus b squared is equal to c squared. Pythagorean theorem, a squared, b squared, c squared. I'm going to cheat here, and this result is 35.9 miles per hour. So his boat on its own would go 35 miles an hour, but the current pushes him, and he actually picks up a little bit of speed because the hypotenuse is obviously the longest side. So it's going to pick up a little bit of speed, 35.9 miles per hour. He picks up speed, but unfortunately he goes off course. He's not going to hit this house. I'm going to make the house look better. Okay, so now where does he end up going? It's not exactly west that he wanted to, so we got to figure out angle A here. So angle A is going to be, I'm looking at it, opposite, adjacent. This is going to be tangent. And then opposite is 8, 35. You're going to need a calculator there. And then you'll get that angle. This angle is going to equal angle A right there is going to be 12.9 degrees. So his direction is 12.9 degrees south of the west line. South of west. Okay, and that is 26. He picked up some speed, but he's a little bit off course. Now 27. This is where he wants to end up, at this house. he's a little bit pissed off if he's not paying attention. So 27. At what angle should the boat head upriver in order to travel directly west? So if he starts here and he wants to get to this house, and we'll do 27 underneath here, he's going to have to steer his boat upwards. And then the current's going to push him down, and then hopefully he can adjust to a point where he gets to hit the house directly west. So let's kind of redraw this picture here. Here's the river again. Here's Mr. Boat Guy. And he sees the house across directly west of him, but he also knows there's a current. So instead of going directly west like the previous problem, he's going to steer this bad boy up a little bit. That's the magnitude of this boat. That's 35. That's the speed. So I'm going to put 35 miles per hour. And he knows this current is going to be pushing him. And now the current pushes him down. And that will be 8 because that is the magnitude of the river, the current. And if he adjusts his boat correctly, he's going to head directly west. And he will hit his target, the house. Now, what is the question for 26? At what angle should he head upriver? So he needs to jam his boat upwards. We're going to figure out this angle B here, because that's the direction that he's sending the boat. He's maxing it out, and then the river current straightens him out, and he'll hit home. So we're going to figure out this angle here. So that's the direction, and we're going to go opposite hypotenuse. By the way, this is not the same number as A, angle A from the previous one. This is a different angle measurement. So we are going to go for angle B here. This is opposite hypotenuse. We're going to go sine, inverse sine, of course, because it's a missing angle, 8/35. And this will end up being, angle B will end up being 13.2 degrees. And so his direction is 13.2 degrees north of the west line. And that's the answer for number 27. And that's all they asked for 27, is spinning it up this way. They didn't ask for what is the length of this vector. Now you could solve this, and because he's sending his 35-mile-an-hour boat against the current, he's actually going to slow down. It's going to be slower than his typical 35 miles an hour. If you do a squared, b squared, c squared, you will see that he actually goes a little bit slower. Well, that's an ugly 5. And it actually ends up being approximately 34 miles per hour. So the current slows him down. But they didn't ask for that, but there it is. Number 26 and 27. All right, now we're going to take a look at 28 on page 456. Again, another vector problem here. So let me quickly read it here. 28, aviation. A twin-engine airplane has a speed of 300 miles per hour in still air. Okay, so we got a plane here. Let's just write some basic information. It goes 300 miles per hour. When we draw the vector, that will be the magnitude. Suppose that this airplane heads directly south. All right, so it's going to go this direction, south, and encounters a 50 mile per hour wind. So we've got wind going 50 miles per hour due east. And so the wind is going east. Whoa, a little blurry. Find the resulting speed and direction of the plane. Round your answers to the nearest tenth. So if there was no wind, this plane would just be going south. So let's kind of just draw this. If there was absolutely no wind, this plane would just go this way. And everything would be happy, and it's going 300 miles per hour. That's the magnitude. And it ends up here, whatever his destination is, Hawaii. But there is wind. And the crosswind is going directly east, pushing the airplane this direction. The magnitude is 50, so I'll put a 50 there. And unless the pilot is a complete idiot, and let's assume that he is, he's not paying attention to the fact that there is wind pushing him. He ends up taking this route and missing Hawaii. So now, what is the resulting speed? We're going to figure out that red line's length, which is the magnitude. So the magnitude of that red line, or the speed, And if you notice this right triangle here, we'll go a squared, b squared, c squared. Notice the c squared is the hypotenuse. So this, he will actually pick up speed more than 300. And so you just do a squared, b squared, c squared to get his speed. And if you do this correctly, I'm saving us time here. This is 304. 304 miles per hour. He picks up actual little bit of speed, but he's going to miss Hawaiian Islands because he's going off kilter. So the next question is, well, what direction is he going? He's not going directly south. We're going to figure out this angle here. So this is for the direction. Again, look at this right triangle. You've got adjacent, hypotenuse. So you're going to say angle A is inverse cosine because we're going to figure out the angle. We're going to say adjacent over hypotenuse. Oh, if you didn't put that 304 there, you could have went angle A and used this 50 is opposite adjacent. You could have used tangent 50 opposite over adjacent 300. But I put the 304 there, so I used that. But in any case, in both cases, you will get an angle of 9 degrees. And so our direction is 9 degrees. It is going east of the south line. Okay? And that is 28. There's the direction. And here is the speed, or in which case the magnitude. The actual airplane ends up doing this route. Whoops, that's a ugly looking airplane there, but that's the airplane.